Hello there. Today we're looking at the volume of a pyramid, and we'll be also looking at the volume of the cone. There's a simple formula that we are using, and we don't need to know the derivation. We will simply take these formulas as the formulas that we need to know and memorize. So here is the formula. Very simple to remember. If you have a pyramid, then what you need to do is simply find the base area of the pyramid and find the corresponding prism. So in this case, if the base area is A and the height of the pyramid is up to that section, just draw a straight line here, up to this section, the height of the pyramid is H, which is the same as the height of the corresponding prism, then the volume of the prism is A into H. Now the volume of the corresponding pyramid is going to be 1/3 A into H. So that is the volume of the pyramid. Very simple to remember. So let's look at a couple of examples. First example, find the volume of a rectangular pyramid. The base is 6.2 centimeters and width is 4.5. So it's a rectangular base pyramid, and the base area is 4.5 times 6.2, and the height of this pyramid is 9.3. So this is the height. So if I have to find the corresponding volume of the pyramid, the volume of the pyramid is equal to 1/3 base area into height of the pyramid. So that is 1/3 4.5 into 6.2 into the height is 9.3. Of course we have centimeter cube. Use a calculator to get this answer. Second example, a square pyramid. So the base area should be A is equal to, has a volume of 625. Perfect. So this is slightly different. We have the volume of 625 centimeter cube, I believe it should be centimeter cube, and a height of 12 centimeters. So what is the length of the side of the square? So we need to find the A into H, and the 1/3 of that is my volume. If I find the A, I can find the corresponding area of the base, which happens to be a square. I can find the side of the square, correct? So volume has been given as 625 is equal to A into H is 12 divided by 3. Therefore A is equal to 3 into 625 divided by 12. Corresponding side of that square will be square root of A. So let me just put the whole number here. So that is 3 into 625 divided by 12. You can use the calculator to get the answer. That is actually 625 divided by 4, and you can find the side of the square of the square pyramid, and that should be in centimeters. All right, one more example here. It says calculate the volume of the pyramids in the picture. So here I have EB is 6.5, so this is 6.5, and BC is 6.5, so this is a square base pyramid, and AO is the height is 12 centimeters. So of course my volume is equal to A into H, which is the base area is 6.5 square, into my height is 12 centimeters, and multiplied by 1/3. So that should get me centimeter cube. Okay. In this case, second example, I have AO, which is the height, which is this one, of this triangular base pyramid, So I will need to find the area of the base. BC, that is the base, is 26.2 of the triangle, and the DM, the height of the triangle, is 16.8. So the base area of the triangle is going to be half base into height, which is half 26.2 into height is 16.8. Now my volume is equal to A into H, which is equal to my base area is, of course we'll get the figure from here, and my H is 10.5, and of course this is 1/3, so divide by 3 centimeter cube. Okay, let's move on to a very similar concept, but now in this case the volume of the cone is 8.06. Same formula again. Corresponding prism, here it happens to be a cylinder, so my base area is pi r square, and my volume of the corresponding cylinder is pi r square h. And of course my formula says my volume of the cone is 1/3 pi r square h. So this is the formula that we need to know. It's very similar to the formula of the pyramid. Here let's look at these two examples quickly. Find the volume of the cone with a radius of 6.2. So the r is equal to 6.2 centimeters and a height of 5.8. Give your answer correct to three significant figures. My volume is equal to 1/3 base area into h, that is 1/3. My base area is pi 6.2 square into my h is 5.8. Of course, get the answer using the calculator. Let me use my calculator. We need to get the three significant figures. So my answer is pi okay, let me, yeah, there's my calculator. Sorry for the delay. So many calculators on my phone. I'm so sorry, I'm not able to locate my right calculator, and I don't have my scientific calculator. Please can you check the answer and make sure this is to three significant figures, three sig figures, and of course the units would be centimeter cube. Okay, in the second example, use the Pythagoras theorem to calculate the h. Of course I need to find the h. H is equal to root of 7.5 square minus 3.6 square, and then use 3 decimal places, 3 dp, and then use this value to calculate the volume. So volume is equal to pi 3.6 square, the whole thing divided by 3 into h from with 3 decimal places from above, and make sure it is 3 significant figures. So answer should be centimeter cube, 3 significant figures. Okay, so that's the example. There's a couple of interesting examples here. I'll just go through quickly, so when you attempt them you know what you're looking at. Find the volume of the solid. Here there's a cone, and the base area of the cone is the circle with the radius of, or rather diameter of 17.5. You can find the base area, and the height is 8.5. So you can find the volume of the cone. Add that volume to the volume of this cylinder with a diameter of 17.5 and a height of 5.8. Okay, in this case I can find the whole volume of the complete BO as the height of the cone, and then I can find the missing cone and subtract it from the bigger volume. That should give me the volume of the cone. Now they've given you these dimensions. One is 8.2, one is 8.2. So this is both equal distances, that and this is same. So you can find 16.4 height for the larger cone, and the smaller cone is 8.2 height. And the radius for the smaller cone is 3.8 and the bigger cone is 7.6. That's pretty easy. In this case, you will do the same what you did here to find the truncated cone, and then you will find the cylinder add to the volume. This one seems to be interesting. The sector shown is formed by a cone by joining two radii. Okay. Calculate the volume of the cone correct to the nearest cubic meter. Now, if we look at this, this is going to be the slant height, correct? If I know the slant height and I need to find the 2 pi r, so 2 pi r of the base of the cone, if I try and draw this cone correctly, so if I find this cone, so this is going to be my r, right, and this is my slant length. So my slant length being 12, if my r, this slant length is 12, r is not known, I need to find the h. Do I know the r? We can probably find the r from here, because the 2 pi r is this one is equal to 2 pi r is equal to a fraction 240 over 360 . So 240 over 360 into, what is the circle with the complete area of the circle with the radius of 12 is pi 12 square. So if I have pi 12 square, I'm taking a fraction that is a sector, it is a major sector, with an angle of 240 over 360, I can find r from this equation, correct? Once I find the r, then I know this r, I know this hypotenuse 12. In this right angle triangle, I can find h. Once I can find h, I can find the volume of the cone with the base area r being this. So pi r square into h, and 1/3 of that will give me the volume of my cone. Okay, so let me write this one again for you. So this volume of the cone, so volume of the cone is 1/3 pi r square h, where r is calculated from this portion and h will come from this right angle triangle. Okay, thank you so much and best of luck. Please complete those exercises and we'll see you in the next session.